now going to see what happens when we make a single bond between two carbon atoms, both of which are sp3 hybridized. We can observe this in the molecule ethane, and from a Lewis structure point of view, it's easy to rationalize that ethane is made up from 6 hydrogen atoms and 2 carbon atoms, each carbon atom having 4 valence electrons. Each valence electron is in an sp3 hybridized orbital, and that sp3 hybridized orbital can be used to make a bond with the s orbital of hydrogen. This will make a sigma bond. We find 4 CH sigma bonds in methane, and here in ethane we can see 6 CH sigma bonds. There's another sort of bond possible in ethane, and that is where this sp3 hybridized orbital of one carbon is involved in making a bond with the sp3 hybridized orbital of the other carbon. This will also form a sigma bond. In Lewis structure, this is depicted with 2 dots, and the bond between carbon and hydrogen is indicated by a dot and an X. The carbon-carbon sigma bond is more formally known as a carbon-carbon sp3 sigma bond to fully elucidate the component orbitals. Ethane can be depicted in a number of ways. None of them are the pure truth of the reality of the molecule ethane, but they all have an aspect of the truth, so it's an important thing to be able to understand each depiction of ethane. When we think of ethane, we can see common characteristics of an sp3 hybridized carbon. For one, we can observe the angle between bonds. This angle is 109.5. That was the same angle between bonds in methane as well. The distance between the 2 carbons in a carbon-carbon sigma bond is 154 picometers.